Hello and welcome to the acid-base reaction and titration video. So in the previous video we talked about the fact that acids are easy to identify. Compounds starting with hydrogen that aren't water are going to be acids. So H2SO4, HNO3, HCl, these are all common examples of acids, and we can identify them because they start with H. The bases are a bit trickier. We talked about in the previous video that hydroxide ions act as bases, but there's other bases as well. And so we don't have the tools to really recognize a base, but we can memorize a really short list of common bases. And so those common bases are going to be ionic compounds containing the hydroxide ion, ionic compounds containing the bicarbonate ion or carbonate ions, as well as ammonia, the covalent compound ammonia right here. So protons react in a 1-to-1 ratio with hydroxides to form water molecules. Protons react in a 1-to-1 ratio with bicarbonate ions to form water and CO2. And this is important because this is the bubbling you see when you mix baking soda and vinegar together. But also this reaction is used a lot in baking because that CO2 creates bubbles in our bread to make it fluffy rather than really dense and hard. And then right here, 2 protons plus a carbonate react from water and CO2. This reaction is very similar to the one above, but we have 2 protons required for the carbonate. And then finally, 1 proton plus NH3 react to form NH4. And this is, again, an important reaction from biochemistry because related compounds in biochemistry do similar things. So how do we use these equations? Well, what we're going to use them for is problems like this. We might be given an acid and a base, and then asked to predict products and balance the equation. And so here we have our acid. It's clearly identifiable by the fact we have a hydrogen listed first. And our base, we know this is a base that has hydroxide ions, and they're listed on the previous page. So if we bounce back to the previous page here, we see that 1 proton reacts with 1 hydroxide to make 1 water. Our base here contains 2 hydroxides, so this means we'd need 2 acid units in order to neutralize both those hydroxides. So 2 protons plus 2 hydroxides will make 2 waters. We know that based upon the equation on the previous page. If 1 proton plus 1 hydroxide makes 1 water, 2 protons plus 2 hydroxides will make 2 waters. We also have spectator ions left over. We have our magnesiums left over, and we have our nitrates left over, so we also form the ionic compound magnesium nitrate. And these acid-base reactions will generally form an ionic compound in addition to whatever waters and CO2s we might be forming. So on the next page we have another example of an acid-base reaction. We have magnesium carbonate reacting with HCl. So if we bounce back to our example equations here, we know that 1 carbonate requires 2 protons in order to be neutralized. So what we see here is that our carbonate is going to require 2 HCl's to provide those 2 protons to neutralize it. And so 2 protons plus a carbonate ion will form 1 CO2 and 1 water. But in addition to that, we have leftover ions as well. We have our magnesium ions left over, as well as our chloride ions left over. So our other product of this reaction, our ionic compound, is magnesium chloride. Alright, so I'd like you to please pause the video and complete questions 1 and 2. Let's talk about acid-base titration. So acid-base titration is a very popular method. And so in the experiment that we're going to be doing, we're going to be taking an acid of unknown concentration and putting it in our flask and testing it with a base of known concentration, which goes in our burette. And the burette's essentially like a long graduated cylinder with a valve right here we're going to use to dispense our base. And essentially by looking at how much base is required to neutralize our acid, we'll be able to determine the concentration of that acid. And so other key pieces of equipment right here, notice the burette's held by this burette clamp, the purpose of which is pretty simple. It keeps the burette from spilling, tipping over, breaking, things like that. And the burette clamp is going to be anchored to this stand right here. Notice right here, it's a little hard to see in this picture, it's easier to see in that one though. We have our stir bar in the flask, and that just keeps everything mixed. And our hot plate is going to be used as well, though we don't use the heating feature, we will be using the stirring feature on the hot plate. And so here's a little bit of a close-up. There's the stir bar, here's our valve, and the scientist is using the valve to dispense, in this case, the base into our acid of unknown concentration. And so right here, how do we know if our reaction is going to be completed? Well, we're going to use what's called an indicator. And you'll see in the following pictures here, the color is going to change once our acid-base reaction is complete. So the markings on the burette are much easier to see in this picture here. They're marked like a graduated cylinder, and we use this valve to carefully dispense it. We'll be demonstrating this in a future lab. And so, as we add our base to our acid, we see these splashes of purple, and they'll disappear pretty quickly. But that shows where our solution's basic. But as the acid uses up that solution, that base is going to turn colorless again. And so we're going to keep slowly and steadily adding our base in a controlled way until we end up with this lasting purple color throughout the solution. And we want a really faint purple color, a really faint pink color, because if it gets too dark, that means we've gone too far. And so once we reach this point, it means we've added enough base to completely neutralize our acid and that our reaction's complete. So this is where we want to stop the titration. And it's a little bit tricky. With practice, you can get really good at this. You'll reach the point where you can stop it at the very drop that causes that whole color change to occur. We'll be practicing this and talking about this more in lab. So once we reach this endpoint, what do we do with that data? Well, this next problem here shows us the math involved. We're asked, what is the molarity of an HCl solution if 18.5 milliliters of a 0.225 molar sodium hydroxide solution are required to neutralize 10 milliliters of HCl? Whew, that's a mouthful. So what are they talking about here? What they're saying is we placed 10 milliliters of HCl down in that flask with the stir bar, and we had to dispense 18.5 milliliters of sodium hydroxide to reach that point where the solution changed pink in order to neutralize all that acid. And we know the concentration of the sodium hydroxide. So how do we set up the math here? Well, it's actually not too hard. We're going to take our milliliters of base, or milliliters of the material we know the concentration of, and we're going to start out right here by converting that to liters. So that's going to be 0.0185 liters. Why do we want liters? Well, we have to cancel out the liters and the molarity right here. So here's our molarity of sodium hydroxide given in the problem. 0.225 moles per 1 liter of sodium hydroxide. So our liters here are going to cancel. And then we're left with moles of sodium hydroxide. So now we're going to use our balanced chemical equations. This is like sort of a stoichiometry problem right here. For every 1 mole of sodium hydroxide, that's going to be 1 mole of HCl, so those are going to cancel. And we're going to end up with 0.00416 moles of HCl. But the question doesn't ask for moles, it asks for molarity. We want to convert that to molarity, so we have to divide that by liters of HCl. So here's our liters of HCl. Or excuse me, our milliliters of HCl, we have to convert that to liters by dividing by 1,000. And then we divide this by our liters, and we end up with our answer here of 0.416 moles per liter HCl. So in the lab, you're going to have very similar calculations. You'll have different values here, but the setup will be exactly the same in the lab. And also there'll be quiz and exam problems like this. So please pause the video and complete questions 3 through 6. And once you finish that, then I'd like you to go ahead and discuss in the discussion board. Thanks, guys. Bye.